Hello, this is Group 21's presentation on macronutrient digestion. Digestion begins with the mouth and ends with the anus, and everything in between is known as the gastrointestinal tract. Our macronutrients are proteins, carbohydrates, and lipids, also known as fats. Beginning with proteins. Whatever we eat, whatever it may be, we always start with the mouth. We chew it. This process is called mastication. We break down that food to increase its surface area in order to, with further ingestion, have easily accessible nutrients that are basically ready to be taken up by our body through absorption. In the mouth, with proteins, there is no nutrients that are absorbed. When mastication is finished, the final product is called a bolus, which is that ball of chewed up food right in the back of your throat, ready to go down the esophagus. As that bolus slides down the esophagus and reaches the stomach, there's going to be some churning and mixing that occurs. This is known as peristalsis, which are essentially wave-like contractions, the body's attempt at smoothly moving that food down the GI tract. Chemically, the stomach will secrete hydrochloric acid, which will hydrolyze and denature the protein. Now we have to denature these proteins because they are extremely complex chains, and we need to straighten them out into their simpler forms so we can easily uptake them. Now, the enzyme pepsin will break the peptide bonds of all these protein molecules and break them down into simpler polypeptides, which we know as amino acids. These amino acids will continue through the stomach. Our final product here is chyme. Moving from the stomach, we go into our small intestines. Mechanically, peristalsis continues to occur while segmentation does as well. These two are very similar in nature, the only difference being segmentation will actually slow the movement of food down, so we can actually absorb all the necessary nutrients that we are getting from that food and nothing goes to waste. Chemically, from the pancreas, we're getting pancreatic enzymes known as trypsin, chymotrypsin, and carboxypeptidase to break these polypeptides down, which we know as amino acids. This is the hydrolyzation, and it results in smaller units called peptides. These are the simplest forms of our amino acids. Our final product here in the small intestines, being those amino acids, can be absorbed through the intestinal lining straight into the hepatic portal system, which will take those amino acids into our bloodstream, and then they can move wherever they need our body to. Now, since those amino acids have actually already moved and transitioned through the intestinal lining into our bloodstream, once we get to the large intestines, all of the essential nutrients have already been broken down and absorbed. So, here in the large intestines, the peristaltic movements continue to occur, pushing that waste product to our anus, eventually leading to excretion. Switching gears a little bit, let's talk about carbohydrates. Here in the mouth, mastication of food always occurs. But chemically, we're getting salivary amylase from the salivary glands that's going to break down these carbohydrates known as starches into simple, smaller sugar molecules. So, after we're chewing, the final product being that bolus that we're about to swallow, we're also going to have readily available sugar molecules ready for uptake by the time that bolus slides down our esophagus and moves into our stomach. So quickly transitioning into the stomach, we're getting that same churning, mixing, peristalsis that it's occurring with all of our macronutrients or any type of food that we do consume. And in the stomach, hydrochloric acid once again is going to come into play, but here it does something a little bit differently. It is going to break down that salivary amylase, and essentially that carbohydrate is going to be put on pause because we don't want to absorb anything until that food slides further down our GI tract. So from the stomach, once it moves from that pyloric sphincter into our intestines, all we're really pushing forward is that chyme and that sugar molecule that we've already broken down. Now here's where it gets a little bit interesting. These carbohydrates, as they move into the small intestines, so that segmentation process that we already talked about is going to slow that food down to make sure that we get absolutely everything that we need from that food. Now, pancreatic amylase and border enzymes are released to further do some work on these sugar molecules. We essentially want to take any type of simple or complex sugar and break it down into its most basic form, which is the monosaccharide. Now, these monosaccharides can pass through intestinal mucosa via facilitated diffusion, and from facilitated diffusion go right into our bloodstream, giving us the energy we need. Carbohydrates are our body's primary fuel source, so they're kind of like the most important macronutrient that we can ingest. Our final product, once we're moving from the small intestine to the large intestine, is that glucose from the monosaccharide that is sent through the hepatic portal system, which basically feeds that glucose, that glycogen, all that sugar, all that good stuff, all that energy and fuel into the bloodstream. Now, as that food pushes from the small intestine to the large intestine, villi will remove the water from any undigested material and return it to the bloodstream. Any carbohydrates that were not digested in the small intestine will be broken down by bacteria. Fiber, which is a common part of any type of carbohydrate, which cannot be digested via the sugar model that we just discussed, will be pushed through and excreted with the feces. Hence, why fiber makes you poop. And lastly, lipids are fats. Mastication occurs as usual. Here, lingual lipase will be secreted and released into the mouth. This is going to make our triglycerides of our fats, because our lipids are our fats, and an emulsifier is essentially that fat or that substance suspended into water, so we're going to get tiny droplets that are going to be ready with that bolus as we swallow. As that bolus moves into the stomach, the same peristalsis will occur. Gastric lipase is going to be secreted from fundic glands. This is going to hydrolyze about a third of the triglycerides into diglycerides, then from a diglyceride into those free fatty acids, once again taking a complex nutrient and breaking it down into its most simplest form so it's easily to be absorbed. Once we get into that small intestines, segmentation plays a vital role. Bile salts from the gallbladder are going to be released into our duodenum, and these emulsified fat droplets are going to break down into smaller fat droplets. Pancreatic lipase is going to be released into the duodenum as well. This is our primary hydrolyzer. Hydrolyzer, as we already discussed, is the breakdown process. Now, once these lipids are broken down into monoglycerides and fatty acids, they can transport into these micelles. So, our final product is going to be those monoglycerides and those free fatty acids. Now we can absorb them from the lacteal and move them into the lymphatic system. Now these short and medium-sized fatty acids that get absorbed in the bloodstream are very, very crucial. They're our last resort energy source. Our bile is going to be recycled through the enterohepatic circulation. Now these micelles that we just talked about are what carry the monoglycerides and those free fatty acids into the microvilli of the small intestines. Essentially, we want to get all of our macronutrients somehow into our bloodstream so they can be circulated throughout our body and used accordingly. Let's remember that food is energy, and energy is our body's fuel so we can function and perform any daily tasks of active living. In summary, my name is Jeff Amaral. I was the speaker for this presentation, and as you can see, here are the contributions to the PowerPoint slide. Thank you.